Hello and good afternoon, dear students. So in today's class we are starting with question number 18 part 1. Okay, so this is the question given to us. Now what we'll do out here is, first it's not given in the form of linear differential equation, so we'll try and make. Okay, so therefore what will I do, I can take this to the right hand side. So y into dx, then this becomes minus x minus y square into dy. Okay, so this is what I am getting. Now if I drop this dx here and this here, then what will be the situation? We'll see. Okay, suppose if I do this, x minus y square is equals to dy by dx, then there will be a problem for me to make in the form of dy by dx plus py is equals to q. Remember, this is linear differential equation of first order in y, and the second one, dx by dy plus px is equals to q. This is linear differential equation of first order in x. Okay, so if I write the equation in terms of dy by dx, then here I'll be having some problem. Here I'll be having some problem because I have to get in this form, which I'll not get. Okay, so sorry, there's minus also. So instead of finding the value for dy by dx, what I can do is I'll find the value for dx by dy, and that will be easy for us. Okay, so therefore at times you have to check whether it is easy for you to get the value for dy by dx or dx by dy. Okay, so here I'm finding the value for dx by dy, which means it will be linear differential equation of first order in x. Remember that. Okay, so dx by dy, then this will be minus x minus y square divided by x. I hope you're clear with this. X or y? Y, right? Y. I hope you're clear with this. So therefore this will be dx by dy. I'll open the bracket. This will be minus x by y, minus and minus, plus y by y square by y will only be y. Okay, now let's bring this side. So therefore dx by dy plus, can I write this as 1 by y into x is equals to y. So if you see out here properly, then this equation is a linear differential equation of first order, linear differential equation of first order in x, with p is equals to 1 by y and q is equals to y. I hope you're clear with this. Okay, we are doing the second type of linear differential equation. Now the integrating factor will also be changed. I think so I can clear this part at least. Okay, so therefore your integrating factor will be e to the power integration. It was p dx, right? But that is for linear differential equation of first order in y, but this is linear differential equation of first order in x, so hence it will be e to the power integration p dy. Alright, will be dy. Please make the changes out here. I hope you can relate out here. If it is linear differential equation of first order in y, then it will be dx. If it is x, then dy. Okay, so e to the power, what is the value for p? 1 by y into dy. Therefore this is log y, and therefore this is only y. So what is my integrating factor? What is my integrating factor? Y. So if y is the integrating factor, then I know the value for p, I know the value for q. Now I can find its solution. I hope I can clear this now. Please pause the video and note it down. Okay? Alright? Therefore the solution will be, its solution is also given by x into integrating factor is equals to integration q into integrating factor dy plus c. I hope you can make the changes out here now. Okay, I hope you can see the changes. X into, what is the integrating factor? Y, which equals to q. What is the value for q? Y itself. Integrating factor y into dy plus c. So hence it is y squared. So therefore when we integrate, it will be y cubed by 3 plus c. This is our answer. So pause the video and note it down properly. Alright, even if you see question number 18 part 2, things are going to be same. Okay, like I said in part 1. Because see, if I find the value for dy by dx, then I'll get y by x plus 3y square, and this will be difficult for me to make in the form of dy by dx plus py equals to q. Okay, so instead of finding the value for dy by dx, what will I do is I'll find the value for dx by dy. Are you understanding my point? I'm not finding the value for dy by dx. Instead, I'll find the value for dx by dy, which will be x plus 3y square divided by y is equals to dx by dy. Are you people understanding? Great. Okay, so therefore dx by dy is not so difficult also. Let us separate it. This will be x by y and plus 3 into y, isn't it? Let's bring this side. So therefore dx by dy, this will be minus 1 by y into x, alright, is equals to 3y. Hence it is a linear differential equation, okay, linear differential equation of first order in x. Okay, please make the changes with p is equals to, with capital P equals to minus 1 by y and q is equals to 3y. Okay, p and q we got. We'll find the integrating factor. Its integrating factor is given by e to the power integration p into dy. So e to the power, the value for p is minus, so minus is a constant, 1 by y dy. Therefore this is minus log y, the base is e, so e to the power, I have said you before, so if the coefficient of log is minus, take it to the power, it becomes log y to the power minus 1 base e. Therefore this is y to the power minus 1, which is 1 by y. So hence the value for integrating factor is 1 by y. So we got the integrating factor. Now it's very simple to find its solution. Okay, so I think so I can clear this. Please pause the video and note it down till here. Right, therefore its solution now, we're just left with its solution. Solution is given by x into integrating factor 1 by y is equals to integration q, 3y into integrating factor 1 by y dy plus c. Y cancel out, so x by y is equals to 3 is a constant, integration of only dy, which is y plus c. So this is our answer. So please pause the video and note it down. So I hope you are clear with this second type of linear differential equation. Okay. Alright, we move to question number 19 part 1. In 19 part 1, this is the equation given to us. So clearly we can see here is dy, here is dy. So what I'm doing is I'm taking this part to the right hand side. It becomes minus x dy, and after that I'm taking dy common, so which is this. So clearly from here it's easy for me to find the value for dx by dy, which is e to the power minus y into log y minus 1. Okay, let's bring this x this side. So dx by dy plus x is equals to e to the power minus y into log y. If you identify this, then this is again linear differential equation of first order in x. Okay, with the value for p as, what is the value for p? 1, and q as e to the power minus 1 minus y into log y. Okay, so therefore integrating factor will be e to the power integration dy, that is e to the power of y. Okay, and its solution now, its solution is given by y into integrating factor e to the power y is equals to, sorry, x, not y, no mistake. Okay, solution is given by x into integrating factor, which is equals to integration q. Where is my q? E to the power minus y into log y into integrating factor dy plus constant c. Okay, so therefore x e to the power y. Now e to the power minus y, e to the power y will be e to the power 0. You don't have to do anything. So log y into dy plus c. What will I do out here? Please use ILATE. So 1 ILATE. Okay, so algebraic function and logarithmic function. So this is my u and this is my v. Let us use our u into v rule. I think so I need more space, so I think so I can clear this. So please pause the video and note it down till here. Alright, so therefore I'll do my integration parts by parts from here. Okay, so x into e to the power y is equals to log y integration dy minus curly bracket d dy of log y. Okay, and then I'll clear this as well. Okay, and then integration dy close dy plus c. Okay, so I hope you're understanding this. I'm just using the formula. This becomes y into log y minus within the curly bracket 1 by y into y dy plus c. It's very easy, just you have to use the formula. Y cancel out, so x into e to the power y is equals to y into log y gone, so integration of dy is again y plus c. So this is our final answer. Okay, so pause the video and note it down. Alright, let us proceed with question number 20. In question number 20, the question is tan inverse y minus x into dy is equals to 1 plus y squared into dx. Okay, so from here I am finding the value for first dx by dy. So dx by dy will be tan inverse of y minus x divided by 1 plus y squared. Okay, and now what to do? Split it term by term. This by this minus this by this. Okay, third step, take this to the left hand side, it becomes plus. That is 1 by 1 plus y square into x is equals to tan inverse y by 1 plus y square. And if I see this properly, then it is in the form of linear differential equation of first order in x with p is equals to 1 by 1 plus y square and q is equals to tan inverse y by 1 plus y square. Alright, so these are the value for p and q. So now what to do? We need to find its integrating factor. Its integrating factor is given by e to the power integration p dy. Okay, now if you look at this integral properly again, then this is your standard integrals 1 by x square plus a square. So hence it is tan inverse y. So e to the power tan inverse y. Am I clear? This is the integrating factor. Its solution is now simple. X into integrating factor is equals to integration q into integrating factor dy plus c. Okay, so now we need to solve this. Let us keep it as equation number 1. Now we'll solve this integral, okay, by substitution method. So please pause the video and note it down. Now here I is equals to tan inverse y divided by 1 plus y square into e to the power tan inverse y into dy. Okay, so let us assume that p, not p, let's take z, okay, or any of the variable r. Let r equals to tan inverse y. So if r equals to tan inverse y, dr by dy will be 1 by 1 plus y square and dr will be 1 by 1 plus y square into dy. Okay, substitutions. Therefore, our I will be, see I've taken this as I, this whole integral as I. Now I will be, tan inverse y is r, into, this will be e to the power r, and dy by this will be dr. And again I have to use now integration by parts. It's a bit lengthy, okay, so I equals to, which is my first function, ILATE, r, e to the power r dr minus differentiation of r, okay, integration e to the power r dr and then dr. Let's do it quickly. R e to the power r minus, this will be 1, this will be e to the power r, e to the power r into 1 is e to the power r, and again e to the power r plus c. So finally we put the value for r. So r is tan inverse y into e to the power, okay, let me take e to the power r common, okay. So e to the power r common, that is e to the power tan inverse y into tan inverse y minus 1 plus c. This is the value for capital I. this capital I and put in equation number 1, the solution is done. Okay, so please pause the video till here. Important type of questions. Okay, it has already come in CBSE, NCERT example means it has already come in CBSE. Alright, so now what will I do? I'll put this value for I in equation number 1. So I hope you have done this. So finally my solution will be, okay, from equation 1, x into e to the power tan inverse y is equals to the value for I. This is my capital I. Okay, e to the power tan inverse y and tan inverse y minus 1 plus c. So this is my final solution. So pause the video and note it down. Alright, 2-3 questions more. Okay, the next one is number 25 part 1, and out here we have to find the particular solutions. Now particular solutions means we need to also find the value for the constant c using these two conditions. Alright, the equation is this. It's a very simple equation. It is directly a linear differential equation of first order in y, because this is dy by dx and minus 1 and e to the power x. So it is LDE of y in, okay, first order in y with p equals to minus 1, q equals to e to the power x. So integrating factor will be e to the power minus p dx. E to the power integration p dx, p is minus 1, e to the power minus x. Okay, so solution will be y into e to the power x. You know the solution, just check this. Okay, this and this, e to the power 0. So e to the power 0 means 1. So integration of dx means x. Now what to do? You put x equals to 1, you put y is equals to 1 and x equals to 0. So when you put y is equals to 1, this is 1, and you put x equals to 0, this becomes e to the power minus 0. Now e to the power minus 0 means 1 by e to the power 0, and e to the power 0 is 1, is equals to 0 plus c. So hence what is the value for c? C equals to 1. So c equals to 1, put the value for c out here, then you're done. This is our particular solution. Okay, so pause the video, note it down. Alright, the next question is number 25 part 3. The question is x y dash plus y is equals to x log x. Okay, so first we'll make in the form of linear differential equation by taking x common. So take x common, this will be y dash plus y by x is equals to x log x. Okay, so on both the sides now I can cancel x and x, it gets cancelled out, and therefore I'll get y dash plus 1 by x into y is equals to log x, which is a linear differential equation of first order in y with the value for p as 1 by x and q as log x. Again the same thing, integrating factor, when you put this value you will get integrating factor as x. Its solution will be y into integrating factor is equals to q into integrating factor dx plus c. Now here you can see it is in the form of product, so hence I have to use integration by parts, ILATE. So this log x is my u and x is my v. So please find the integration by parts out here. I have solved it, and when you solve it you will be getting this equation after you use the formula. And then finally what to do? Put the value for y equals to 1 by 4, x is equals to 1. Put the values of y equals to 1 by 4, x equals to 1 out here, and you'll get the value for c. Remember, x equals to 1, log 1 will be 0, so the entire thing is 0, and this is 1, so minus 1 by 2. Bring this side, you'll get c equals to 3 by 2. And then finally, please put the value for c back, put c in equation number 1, that will be your final answer. Okay, so pause the video and note it down. Alright, so that's it for today. Your today's assignment will be question number 23, question number 24, question number 25 part 4, part 5, and you can also try part 6. Alright, so with this we have come to the end of this chapter, differential equation. Remember, we have done ordinary differential equation, and out there we have learned about order, okay, degree of differential equation, and then we did separation of variables, okay, separations of variables. Then we did reducible to separation of variables, right? And then after we did homogeneous differential equation, homogeneous differential equation, isn't it? Y is equals to Vx, right? And reducible was y equals to ax plus by plus c. I hope you remember. And then finally we learn about linear differential equation. Linear differential equation of first order in x and first order in y. We have learned about integrating factor and then its solution and then particular solution also. Okay, so this whole is your differential equation, which is very, very important and which carries 8 to 10 marks in ISC. Alright, so far we have completed all these topics in differential equations. We have also done differentiation, we completed integration, and then definite integrals, isn't it? Definite integrals. We also completed integrals. We also completed differential equation. So far we are done with our calculus. A few more topics, if it's there, we will discuss. Okay, and now we have to start our probability. And in probability also, a few exercises, I remember a few exercises we have done in school, right? In class we have done few exercises. We'll come to that later. So please do practice it properly. Our main part is almost over. Our calculus is almost over. Okay, so take care and I'll see you tomorrow in the next class.